We had some that were some errors. Now, if you see it written the way this is written, what do you know that you have to do to get it? What do you know? Factor trees. Do you like the idea of having to do number 5 with factor trees? I don't. I'm being honest. I don't like them. I don't like factor trees, period. I would prefer to do the ladder. But since it says prime factorization, now can I, if I know the factors of the number, the prime factors of the number, I might not have to do the tree. Okay, if I just know it. Such as, what do you know are the prime factors of 4 without doing a tree? What do you know? Bryson? 2 and 2, good. So I can say 2 times 2, right? Now, do I know the prime factors of 18?
Yes.
Ooh. Anybody in here know the prime factors of 18? Brianna?
9 times 2.
9's not prime, can't be the prime factorization, can't be prime factor. What are the prime factors of 18? David?
3, 3, 2.
3, 3, and 2. Good job. So 2 times 3 times 3. Okay? Can I find the GCF of 4 and 18 now?
Yeah.
What's the GCF of 4 and 18?
4.
It's what?
4 doesn't do anything. 2.
It's 2. It is 2. These two got married, right?
Yeah.
They create 1, 2. That's all that's there. The others don't have a partner, do they?
No.
Can't work. What about 10 and 25? What's the prime factors of 10 and 25? Let's do 10 first. What are the prime factors, Brian, of 10?
5 and 2.
Okay, and I'm going to write them because it's prime factorization, and prime factorization has to be written how? Least to greatest. Okay, so I've got 2 times 5. What are the prime factors of 25, Faith?
5 times 5.
There you go, 5 times 5. What's the GCF of 10 and 25, Leah? Looking up here, what's the GCF of 10 and 25 going to be? 5, because these two get married. There's my 5. There is not a partner for the others. Now, if you can do what we're doing right now, and you just know your factors because you have good number sense that works for you, could I maybe avoid having to do the tree?
Yes.
If I just know it. But if I'm not successful just knowing it, like a little bit ago, somebody said 2 and 9. You have to know what's prime and what's not. Okay, so you can't let yourself get tripped up that way. What about 24 and 40? Now, are those two maybe harder to do just from here? 24 and 40. What are the prime factors of 24? Amelia. Okay. Prime factors of 24. You guys figure it out. If you have to do a tree, do the tree. If you can write that prime factorization without doing the tree, get it done. But I want it on your paper. You have to write the prime factorization. That won't give you prime factorization. Okay, what I'm saying? You have to write the prime factorization.
Is that prime?
And then do it for 40. When you got it done for 24, do it for 40 also. That's not prime factorization. Neither one of those. You have to write the prime factorization.
Oh, okay.
Have to. That part you have to do.
I did it.
Yes. Yes. And then we load them up. Yep, I agree. Melissa, please put that library book away, or I'll put it away. Thank you, babe. Is that a 4? No, right next to it is it a 4? Is 4 prime?
Oh no.
So that can't be the prime factorization. Okay, you don't have prime factorization here. You've done a list of factors, but not of prime factors, okay? We're gonna do that. Is 12 prime or is 20 prime? That's not a prime factorization. I don't see prime factorization. Nice job. Nice job. I do not see a prime factorization on either one of those. Okay, there you go. All right. As I walked around, I saw kids. I saw this, and I'm gonna do it over here because I saw some kiddos doing this. Three, 8, 4, 6. And I saw over here we had 1 and 40, 2 and 20, 4 and 10, 5 and 8. These are not prime factorizations because the number 24 is not prime. The number 20 is not prime. 4 is not prime. That's not a prime factorization. Prime factorizations have to list only prime numbers that multiply together to get that number. So this is a list of factors, and yes, it can be used to find the GCF, but it's not prime factorization. You have to be able to write prime factorizations because we're going to use them today to find our least common multiple. So we're to the point now where we have to be able to do this, okay? So what I'm seeing, if that's what you're doing, it's because for some of you, just doing the prime factorization from your head's not working, okay? So that means I gotta have that factor tree. So give me a pair of factors for 24. Give me a pair, Macy. She says 3 and 8. Macy, are either one of those numbers prime? 3 is prime, I'm gonna circle it up. That means I've gotta take branches off of that 8. So what are your factors of 8, David?
4 and 2.
4 and 2. Which one if either one of those is prime, which one?
2.
The 2, okay? And this is kind of an unorganized way of doing it, but you can do it unorganized. I just like to organize it better. But I'll run with it the way you guys are doing it. And so finally my factors of 4 then. Caleb. 2 and 2. Now, Caleb, can you write the prime factorization now for 24? Can you tell me how to write it?
2 times 2 times 2 times 2.
Okay. These are only prime factors when multiplied together equal 24. They're the only ones. Okay? What about 40? What about the number 40? If you can't just do it automatic, you've got to use the tree. Mr. Bryson.
5 times 8.
5 and 8. Bryson, are either one of those prime?
Yeah, 5.
5 is prime. I'm going to bring my branches off of the 8. What are the factors of 8? Mr. Brett, what are the factors of 8? 4 and 2. Is either one of those prime?
2.
Circle it up. What are the factors of 4? What are those factors of 4? Alexis?
2 and 2.
2 and 2. Are they both prime?
Yes.
Sure are. Now, I need somebody to write the prime factorization for the number 40. What is the prime factorization for the number 40? And I'm looking around trying to find somebody that maybe hasn't talked to me yet. Barrett.
2 times 2 times 2 times 5.
2 times 2 times 2 times, and I'm going to throw my 5 out over here. Doesn't matter, does it? Okay. Now, who's getting married? Twos, twos, twos. So 2 times 2 times 2 equals
16.
8.
Oh wait, 8. I thought
My
it was
GCF is 8. Okay? If you can't write the prime factorization just from knowing the factors in your head, you have to do the tree. Have to. Okay? Don't be lazy. It's not a spectator sport. Do the math. Okay? And the more practice we get, the better we become. But if I'm practicing and you're sitting there, I'm going to get stronger at math, but are you?
No.
How many of you play sports? Yeah, I love this. A lot of you guys play sports. Okay. So now, is it fair in saying that we are not all the most gifted basketball player the planet has ever seen? Is that a fair statement?
Yeah.
If we watch Stephen Curry, or is it Stephen Curry? Yeah. If we watch Stephen Curry or KD, that's another important basketball dude, right? Kevin Durant, KD, Michael Jordan. If we watch them play basketball, are we going to become stronger basketball players? No, we're not. We may fundamentally know the game in our brain, like you fundamentally know what a prime number is, but you haven't used it, so you haven't perfected that skill. Right? You may fundamentally know, hey, I know when I shoot a free throw, bend your knees, put the ball in the right, and, the whole flip of the wrist so that it spins right, whatever. But it doesn't mean you're going to hit a free throw every time you shoot it, does it?
No.
But I watched KD do it, so why can't I do it?
You just don't have the skill of playing that basketball.
You didn't practice. Same thing here, folks. If you don't practice it, when it comes time for the test, you're going to fail it. If you don't practice it and you want to go shoot free throws in the Knights of Columbus free throw competition, do you think you're going to be the winner? No, not if you don't practice. Because there ain't no one of you here that is the greatest gift to basketball the world has ever known, right? You got to work at it. Same thing with math, okay? All right. And you may be good at it. I'm pretty good at it. But if I don't do it, I lose it. Do it or lose it. Use it or lose it. That's my slogan. Use it or lose it. Factors of 6. Can you guys write the prime factors of 6? I know I can. Can you? Callie, can you? What are they? 3 and 2. Good. So 2 times 3. There's my 6. There's my prime factorization. What's the prime factors of 15? I think that's another one that you should be able to do. Those are pretty simple ones. What's it going to be there, Miss Melissa?
3, 5.
So the number 15, she says 3 times 5. Okay? What about the number 21? Prime factors of 21. Who's going to give me those? Miss Jessie.
3 and 7.
3 and 7. So 21 is 3. I don't have a 5, but I do have a 7. Do you agree?
Yeah.
Okay? Can I put... That line just means I don't have any more of them. Okay?
Those got upset, please.
I don't have any 5s up here. You'll see why the lines are being used in just a little bit. But where do I have where they're going to get married? It's a little bit strange because there's 3 of them. But what number is going to join together to make one of them? Connor?
3.
The 3. Right there. 3 is my GCF. Do you notice I have a row here where the prime factorization of 6 is? That's a row. Rows go horizontal. Do you agree?
Mm-hmm.
You guys are in rows. Do you agree?
Mm-hmm.
Okay. Columns go vertical.
Mm-hmm.
You think about a porch, and it has a column that holds the porch up. Have you guys gotten into Greece yet? In social studies, have you gotten into Greece? You will, though. And there's a place called the Parthenon, very famous place. And it's this rectangular building with columns that hold the roof up. It doesn't have real walls, just columns. Okay, so they're vertical, they hold things up. Okay, so I have a column of 2s, but how many's in that column?
One.
Only one. I have a column of 3s. This column is full. Do you agree? I have a column of 5s and a column of 7. The only full columns are the 3. G, C, F. Full. F, full. Full columns, 3, that's it. Okay? Bring one from every column. Full column. All right? And I'm stressing that for a reason. Do you have a question? Uh-huh. Yep, I sure am. All right, now then, let's go here. How many of you know what a Venn diagram is? What is a Venn diagram? That's a good question, right? What's a Venn diagram? What is a Venn diagram, Zoe? Compare two numbers or two objects, anything that we're doing a comparison, right? Now, can a Venn diagram compare more than just two?
Yes.
Sure, okay. And so you've seen Venn diagrams and they overlap, right? And what do we know about that part in the middle of the Venn diagram? All right. I want to know, use the Venn diagram to find the least common multiple. Remember, we said multiples. So we're going to do some skip counting, right? And for the number 4, now I like to do mine down here because then I'll put it where it belongs. So I've got 4, 8. Help me out, kiddos.
12, 16, 20, 24, 28, 32, 36.
Okay, I'm going to stop right there. I'm stopping right there because I'm kind of looking at that number 18. Now, I'm going to skip count by 18s. It's a little bit tougher. I have 18, 36. Do I need to go any farther?
No.
Why not?
Because we already have a 36.
Brian, why not?
Because in 18 there's 36 and on 4 there's 36.
Sure is. So I put my 36 right there, right? 4, 8, 12, 16, 24, 28, 32, 20. I can get them all in there. And I can throw 18 out here. The minute I have one that is in common, I stop. I could keep going on forever, but I really don't want to. Do you?
No, why?
Well, just because I could. I could find something else they had in common, couldn't I?
Yeah, but it's not.
But the word is least. The lowest multiple they have in common. Okay? 9 and 16. Do a circle. Do 2 of them. Okay? We know we have 9.
18.
I've got 9. 18. Keep going.
36.
36.
27.
Oh, whoa. Did we miss one?
Yeah, 27. Then 36.
36.
45. 63. 62.
Okay, whoa. 54. 63. Let's stop for a minute. Let's see if we can get, maybe we've gone far enough. We have 16. What's 16 times 2?
32. 32, yeah.
32. What's 16 times 3 going to give me?
48. 64.
And then another 16 gives me 64.
Yeah.
Haven't got anything yet, do I?
No. 80.
So I got to keep going then. 64 plus 16 is 80.
And then. So that means you have to keep on going on the 9s.
96.
100.
100 what?
12. Nope. 112. Yep. Yeah, 112.
Well, we haven't found it yet, have we?
No.
Okay, so 9, 18, 27, 36, 45, 54, 63,
72,
72,
80,
81,
90.
90. 90's not right.
Yeah.
Yeah, it is. I was thinking of my 16, sorry. 90, 99,
108,
108. God,
117.
I'm not thinking I want to do it this way. We haven't got it yet, have we?
Yeah.
There's got to be a better way. There's got to be a better way.
9 times 16.
It's set up.
I'm going to leave it alone for right
9
now, okay?
times 16.
9 times 16, well, that is true. That would definitely be one. But I don't know, is that my closest one?
Probably.
Well, we got 16 at 112. And then we have, after 112, we'd have 128. And we would have 100.
And
No, it's 44.
44.
160.
Yep. 176.
Okay, this is
We're not there yet. Do we want to keep going?
Yes.
Get it done for me
It's
there, Amelia.
144. It's 144. I just went on with nines. It's 144.
108. Tell me the next 9 then.
117, 126, 135, and 144.
So it's 9 times 16.
Yeah.
Yeah, it is.
So 144. I don't like that. I'm going to tell you that right now. Do you want to do that every time you've been asked?
No.
There's got to be a better way.
Got to be.
Okay, let's do 15 and 24. Oh, Mrs. Rakestraw.
15, 30,
15, 30,
45, 60,
45, 60, 75, 90, 105, 120, 135.
Or 150.
Wait, we can.
I'm gonna stop there. I'm hoping that.
24 can go in.
So 24. I have 24, 48,
60.
60, 108.
Hey,
No,
60.
not
60.
Not 108 either. Woo, 60. Good.
Yeah, buddy.
I don't want to use a Venn diagram. Do you want to?
No.
Do you know how to?
Yeah.
Not a choice, right? We don't like
You
it.
don't want to.
No.
Sometimes it's
Okay, so Venn diagram is one way of doing it. I don't want to have to use it. It's kind of like Dad's got a belt, but he doesn't want to have to use it on you. That's kind of the way that Venn diagram felt to me.
He's like, son, get rid
Okay? All right.
paddle.
Okay, ladies and gentlemen, we're going to do a list of multiples now. For 4, I have 4, 8, 12, 16, 20, 24, 28, 32, and I could go some more, right?
32, 36, 12.
Now, I'm going to go with 6s. 6, 12, 18, 24. Oh, you mean I can stop?
Yeah.
Okay. What is the 12? You remember doing least common multiples like this? Have you done them this way before? Okay. But if that number, like what we had a while ago, was 9 and 16, those lists are going to get long. Don't want them. Okay? But we can do them. Show me the list on your paper. Do the list to find the LCM of 3 and 8. Do the list. interesting. As I walk around, I'm seeing two numbers emerge as the LCM, and I know that can't be. I gotta have the smallest one. The lowest, the least. Okay, Brett, tell me the list for the multiples of 3.
24.
Huh?
3, 3, 6, 9, 12, 15, 18, 21, 24. 8, 8, 16, 24. Multiple is 24.
Okay, hang on a minute, bud. I'm trying to write. You're faster than I am, okay? 8, keep going.
16.
24, you're gonna stop.
And 24 is your multiple.
And he says stop. All right. When I walked around, I saw some kiddos that said the LCM was. And I saw others that said it was 24. I don't know. It can't be 12, can it? Because 8 is, okay, listen. I like having fun, but you gotta be focused. If you get an LCM, like you got the LCM of 6, or of 3 and 8 being 12, then that's saying that 3 times something gives me 12, and 8 times something gives me 12. And that's not possible. So at that point, you would know this is not realistic. It's not true. Because I can't say 3 times 8, I can't say 3 times 4 equals 12, that's true, and 8 times something equals 12. That is not true. Therefore, it couldn't be the number 12. So I can check myself. If I say it's 24, 3 times what is 24? And my other one was the 8, and 8 times 3 equals 24. Both of these are true statements. Therefore, I can check it and make sure that it's true. I mean, I might not have gotten the lowest because I could have said 45. No, I'm trying to think of another one. 32. I could have done the next larger multiple, and I could have still thought I was right, but you got to look for the smallest one, okay?
It'll be 48.
48 is the next one.
Yeah.
Okay, so I couldn't check that. List of numbers, are you good with it?
Yeah.
And that's where I'm going to stop. Your assignment for tomorrow. Here's what I want. This is pretty tough. This is pretty tough. You got to do 2 and 3 on your own. Okay? Voices for a minute. You have to do 2 and 3 because the next step is the prime factorization. All right? And hear me. I'm gone tomorrow. So therefore, you're going to just keep this and we'll finish it on Monday because nobody's teaching you prime factorization in this but me. I'm kind of territorial, and I make sure that it gets taught the way I want it taught, okay? Sometimes, if it's not taught the right way, and it's taught the wrong way, you get the wrong way stuck in your brain and you can't fix it. And I don't want it messed up. So we're just going to stop with that. Okay, there'll be something else for you to do tomorrow. Yes, sir. Good. Line up. Just a minute, okay, Bob?